All right, so I think we've got as much as we're going to get here today, but I wanted to go over just a simple class just because debugging in Node.js is a little bit less obvious than in some other language because it's a separate process. It's not as built in as some other things that you might have used in the past, but there's actually quite a lot of different options that are available for debugging in Node.js, and which is primarily, if you're not familiar with Node, it's the main way of running server-based applications with JavaScript. So we've done a few talks in the past about JavaScript, so I'm hoping that you're slightly familiar with JavaScript, or at least aware of what the script, how it works, and things like that. So um, there are a few things that are provided for basic debugging in Node.js that just you'll see a lot in development, and this is just in JavaScript in general. There are a lot of things. Don't worry, it'll be a bigger screen in a second. There's console.log, which is generally like your first go-to if you're just trying to figure out like what is the value that's being passed, and if you don't want to like hook up a whole debugger and step through your code. That's kind of one of the fast ways if you don't have to recompile anything because it's a script. What's that? Oh, so and so console.log is kind of one of the first things. Debugger is kind of nice because that's how if you have a debugger attached, you can throw the keyword debugger in there, and it will automatically stop your code at that location. So it's like it's a breakpoint signal in the script. So if you have a debugger attached, it will stop the code at that spot, guaranteed. Only problem is it's hard to once it's written in there, it's hard to undo that, or rather, unlike the dynamic breakpoints in some inspectors, you can't just like start skipping over it. It'll keep stopping every time. So it's a really hard breakpoint, but it can be useful. It's like, hey, I just need you to stop right here as soon as I attach and run any code. There's the assert library, which is generally used in testing, but it's also there's some forms of programming styles that use asserts as a way of airing out if they get unexpected results. And you can also use it if you're debugging. It's like, hey, just blow up if I'm not getting what I'm expecting because I'm debugging my code. If this isn't 2, like I'm expecting this value to be 2, then please just blow up because that'll help me identify without having to go through all the steps. And then there's a couple different utilities inside the util library that comes with Node called inspect and debug log, and we're going to look into those right now. So here's the script you have the teeny picture of right here. Here's the current large version of it. So just going to go through what all these do, and I'm going to attach a debugger later to show you, or I'm just going to run the code to show what these do, and then I'll attach a debugger and we can step through what's going on. But here's a utility class. This is built into Node.js. It comes with a whole bunch of different implementations to help your life. Here's just a complex object I've built that has lots of nesting, you're going to see a lot of these, and there's even more complex ones that have like self-referencing code, which are even more complex, which some things will break on, and I'll explain what that would mean. Like some of these output methods of just seeing what's happening in the code would not be able to inspect it very well just because of the depth of it. So here's an example of an assert. What it's doing is assert right here just throws an error if this ever returns a falsy value. So if it's false, 0, or null or undefined, that means it'll blow up. Or it'll throw an error. So this would be the idea of throwing the error right here, because I expect this to blow up because that's not what complex object is. It's not an integer, so it's not a 1. So I would have to catch that if I didn't want it to blow up. But generally, you're not going to throw a certain try catch. This is just for demonstrating what that error would look like. Then you have console log. There's a couple different ways of using console log. One of my kind of go-tos, just because I know it's in both languages, no problem, is JSON.stringify. You can pass most objects into it, And what JSON stringify just makes it a JSON object, which for a lot of JavaScript objects have kind of a one-to-one representation uh, as JSON. Not all. So there's some things like hashes and things like that that don't technically map to JSON, but for reading and inspecting what the properties are of an object, that's really kind of useful sometimes to pass unit. The problem with stringify is it does not do deeply nested like self-referential code. So if you have object 1 as a reference to object 2, which has a reference back to object 1, which you can do in programming quite a bit, then it's going to nest as it's trying to inspect that. It's going to keep like, oh, I'll go to object 1 and print out its properties. Oh, object 1 has a thing for property 2. I'll go to object 2 and print out this property. Oh, object 2 has object 1. And then it just goes down and it blows up the stack, is what we would call it. So you wouldn't be able to use JSON stringify in every situation. It's kind of helpful. There's also the other idea with stringify. JSON stringify is going to look for two JSON properties on objects. So if somebody's customized to JSON on an object, it'll use that instead of going through and doing this like custom ways of displaying code. So it's not right in every situation to do this, but it can be useful just to sometimes because it's available everywhere that in Node and on the web. It's good to know this. Just for debugging purposes, it can be helpful to just log out what everything looks like. Just like, okay, just quick. If it's not self-referencing code, it'll be quick. It'll be easy. And this null is you can ignore it, but you kind of need it so you can pass a second parameter. This tells it how many spaces, so it gives a pretty print. Otherwise, you get a JSON blob that's kind of harder to read. Pretty print expands it all out, and I'll show what that looks like in a second. Then in Node versus like the web, you have the util.inspect, which is specifically for debugging and inspecting items. So it's more capable than what stringify is because you can customize to what depth it goes in a self-referencing thing. So it says, hey, put the brakes on after you go 2 levels deep. I don't really care about things nested 2 or 3 levels deep or whatever you want to put it at. Or you can do null and it'll go as far as it can. I'm not sure how it handles if you were to don't set the depth on a forever nested. It might just auto handle it. I think it does, just because it's like, okay, hey, this is going too far. I'll give you the best I can, but don't quote me on that one. I haven't tried it, but so I'll show what these outputs look like. They're slightly different. There's a couple different. And then there's you can also with inspect, just like I was saying with toJSON, like objects can specify a special way of writing out their properties. The same with inspect has a custom way of doing inspections or outputting how you want to look when you're looking at the code. So say you're creating a very complex object. You own this object. You own how to display it, but you know that there's only one value in there that you ever really care about. Everything else is private. You don't care. It doesn't change how things work. You just need to know, hey, does this have the one Boolean track to say yes, it's cache, or no, it's not, or something. And that's all you care about. You don't care about the rest of the information in there when you're doing an inspect. That's kind of what this is kind of showing. Like, oh, you can just basically override and just output the information you really care about on that object. If you say you're inspecting it a lot and you don't ever, or you don't really ever want to look at those other properties that don't mean much to you. So this is one way of customizing your debugging life if you're coming across that, is to be able to define an inspect property and handle it. And there's documentation linked inside the slide for the inspect. So you go there to see exactly how you would go and customize that. This is one of the examples they have on here. And I didn't come up with an example for debug log, but this is a way of putting code into your program. So debug log is a way of putting in debug logs that are only triggered by an environment variable. It's called node_debug. And you can limit it by using things like, let me zoom in for you guys. You can limit it by like tagging your module name, for example, right here, and then you can specify, this is supposed to be a Node's way of providing all sorts of modules a way of outputting more verbose information throughout their code. If they were to use this debug log utility, then you can add debug messages as a module and still ship your code to production without having to worry about debug code and all these extra verbose messages being spit out and just like filling your logs that you don't care about. But you can trigger it by saying like, hey, here's my module name, by setting a property, say foo, or plus comma separators for any other modules, and say, hey, give me the debug information for this module or for my module that I have, and it'll output specific information that you wrote in the log to log out. Here's an example of like comma separated. So you can just see what's going on under the scenes, and this would be, I think these are maybe built-in ones for file system, net, TLS, things that are built into Node. So you can see more debug messages that, hey, what's going on, by just setting this property, and you can do that live against a production server or clone or whatever, and be able to see more information in the logs of what's going on if you need to, without having to rewrite any code or strip out console.logs or throw more in. So that would probably be a better way of going about providing optional, more verbose information in your application for when you need it to trigger. Now let's go run some of this code. So I'm just going to run Node. I have a debugger, that the script we're just looking at is here, Node Debugger.js. All right, so I ran. This is the error that we caught and I just spit out. This is what the assertion error will look like. If an assertion failed, this is kind of the error you're going to expect to get. This is a stringify version of that, really nested. So let me go back over here. That's this object right here, complex object that is really deeply nested. And so if you look at how this stringify printed and printed out, really nice, easier to follow. You could copy that, paste it into a .json file and format it, look at it, investigate it that way. And that's one way of doing it. But once again, it doesn't handle self-referencing code very well. Here's the inspect code. If you look down using the inspect utility, util inspect, here I'm telling to only go to a depth of 2 when it's looking at this object, and I'm telling to show any hidden properties. There are other there are properties within JavaScript that you can completely hide from an inspector unless you pass this in. So if you're just like, I don't care about, if you're making private properties in your object and you're like, I don't want these to normally be seen by people, you can hide them so that they can't be iterated or shown up in a list. But I usually would probably saying true to that just for debugging purposes. But so you see how it says complex object that, and then it just stops right here because it doesn't go any further. It's like it went 2 layers deep because this is the first, second, third, or first and second levels deep, and the third and fourth just like, well, that's just an object. You're not getting any more detail. It's just telling the type of the object that is, what that property is set to, what type it is. And then you can see deep infinite goes through and spits out the same thing as in a really compact way. It's not pretty print, but it could be. There might be things to be able to change it. I didn't look into that. And then we can see here's that box object here's its custom output. That's what it's outputting for the debug. So it's making it a little bit clearer. But now we get to the cool stuff. That was just basic, like outputting as you're running and not being able to interact with it. Now live debugging is a key to understanding how some things work. Sometimes it's hard to visualize what the hell is going on in your program, how it got there, what the values are that it received. And most applications out there since the beginning of computers, we've had not necessarily the beginning, but for a very long time, we've had the ability to run code and pause this execution and inspect what those values were at that point in memory and in execution, what everything is going on. And there's cool things that have been available for Node.js versions greater than 6.3. We have the Node-inspect, which opens up the Chrome dev utility, or gives you a link they can put into your Chrome Dev or Chrome, paste it, and it opens up the Chrome Dev tools. So if you've ever used JavaScript Inspector on the web, the Chrome Dev tools, you'll be right at home using the JavaScript Inspector there. If, for example, you're stuck SSHing in and you still need to debug in a different environment, Node Debug is another great way. It's a console version of debugging and stepping through the code if you need to do that. And it's got, I'll put a link into here afterwards for this, but it's got different commands. You can add watchers, everything you need to for a debug. You add watchers, breakpoints, stepping through. It'll work through there through a console window, and I'll show what that looks like right here. So you can see it's stopping right at the very beginning of the program of debugger. That's util. If we look at this guy, it's stopping at the very first line. Let me see where that. Go back. Index debugging. You have commands. Run. C. Oh, stepping. There we go. Continue. C. There we go. It's like there's commands for it. C. Continue. So now a continue command generally means continue execution until there's a breakpoint. Or and debugger, like I was saying, is an automatic breakpoint. So it's a keyword that you really don't usually want to throw in production code, but if you're on your own system, you just need to throw a quick little breakpoint. You don't want to interact with the debugger or anything like that. That's a great way of like, hey, I just need you to stop the code, run the code until I get to this debugger statement in my code, and then I can start inspecting what is available. And let's see, breakpoint. Yeah, there's a whole bunch of ways of doing this, and I think you can even see what is listed. Flex object. I did not probably spell it the same way. Okay, you can't. It's complex. Yeah. Next. Okay. Yeah. There. Let's see. Can I? Yeah, I haven't actually played around with this, but it's like the documentation's right there. So yeah, it doesn't look like doesn't interface. You probably have to actually use a watch command, like it was saying, watchers. Watch. And next. So now here's my watchers right here. So you can, I think you have to manually set your watchers instead of where with the web version you've kind of got a console that can interact with the code and the memory at that where it's pointed at the moment. Yeah, so I would say read through this. There's commands here. It's fully functional. It's maybe a little bit clunky compared to GUI versions. It's a little bit more command liney, but it's still functional. It's something you could definitely do if you had to SSH into a box and run the script there and with the environment to be able to step through the code and see what's going on.
What is the difference between like the step in, step out?
Okay, so to step into the code is execute the line and go to wherever the next point of code it goes in there. So if it's a method you're calling or a function, it'll go into the very first next line of it inside of it.
Okay.
Step over will say run that next line, but don't take me into it.
Gotcha.
So I don't care about the internals of how this guy works. Just execute it and go to the next line of code, and we'll see what happens.
Gotcha.
And step next is literally just keep going line by line.
Okay.
So we have all those right here. Next, yes. So step next is kind of like step in.
Step in line by line.
Yeah, I think step next is the step over, and there's different terminology for different debuggers. Step over, and is what I'm used to in .NET, which is like, but that's basically step next is in this one.
Going line by line. That's
Yeah.
So the step in is going to the function call. Step out is coming out of the function call.
Yeah, step out is says, okay, I'm inside this function. Go until it finishes or is returned, and take me to where it was called from. So, and continue execution just means go until that you hit a breakpoint, or I manually say pause or something. And you can tell it to pause here. Obviously, like, oh, you're running. Pause now. See where I stop at. It's like something's happening. That actually happens if you got a loop going on constantly. You're like, it's like I'm gonna push this button and then pause and see where. Then we'll follow the stack trace of where I'm at. Usually is what happens. So yeah. So this is available in all versions of Node, the debug tool. Now, right now, my Node version is 6.1, so I don't have that inspect of this one. So we're going to use another tool, which is Node Inspector, which you can install using npm or install Node Inspector for a global, and then you can say Node Debug, and you can tell it the script. So I'm going to show what that one does. There we go. So, all right, now it says I have a debugger. Oops. Yeah. Okay, there we go. It says to go to here. Use it. So I'm going to open that in Chrome. It'll open a window, but okay. And so it brings up pretty much the Node developer tools, and this is using. So it kind of stopped at somewhere with module. So now I'm going to tell it to continue. Now I've got those commands for like stepping over. It remembered my breakpoints from last time I ran against this script. So I could put more breakpoints in here. It's going to go to debugger. I don't technically need a breakpoint there. Now it's going to stop it here. I can see what the complex object is. So I can start expanding what is in here. So this is a full-fledged debugger. Play around with it. This is great for if you're stuck using something that doesn't use the newer inspect. So this is a system-wide utility you install in your box, and then you can run it and against it at that point. And yeah, it's pretty flexible. Console log error. What did I already say continue? I think I finished. Maybe disconnected. I don't know what happened, but assertion failed. Oh, maybe it didn't like that. So it has some limitations and some drawbacks to doing it this way versus using the newer utility. But go look at their website on GitHub, and it talks about the limitations they have. And like one of the things you don't want to really look at is file streams, buffers, because it'll try to send that up as an array of all those binary bytes, and so you're going to be sitting there, it's going to be trying to render a K of data as bytes, which is really noisy, and it might crash the inspector. So just like be careful what you inspect using it, but it's definitely far easier than using the console line unless you get really used to the console debugger. All right, so now I'm going to switch to the newer version. And now we can do this. Oh, and this command right here, debug brk, means it's putting a breakpoint at the very start of executing the script. So nothing in the application is going to, which can be very helpful if you're trying to debug something like your config in Express.js or something like, hey, I need to debug before you do anything else. I want to see what you're doing and load it here. All right, so now we're going to see the newness. All right, so now we have a much longer URL. Chrome DevTools, which you can paste into Chrome. And now this is, you can see it's a little bit nicer in some ways. Let's see, step over next function, step over. All right, so we can, oh, and both of these, the other things you can do is you can live code replace in these inspectors with another cool thing you can't really do with the other command line tools. So that means I can actually start typing in here and say console.log bark. I don't know. And then I should be able to, oh, maybe that'll be the next time. I don't know. It didn't show up. Let's see, console. It's telling me I haven't played around with this feature. But the yellow is saying it's going off. This is the thing in memory is going off. So maybe it would have to reload this module to do it, which you could do. It would be like the next time around and rerun it. So I'd have to play around with that, but I know you can do it, which with applications that have loops like servers or other things that require it, should be able to replace that. I would have to actually play it around. But yeah, it has that feature. You can modify in some cases, I guess. Not all cases. But it's cool that you can like do the same inspectors in here, step over. And it's got better hints on here for showing. This is why you would probably want to use this one. It's got better hints for what the values were last known, so it kind of does watches for you as you go. It's like, oh, that was dep 2. So, and then you've got the interactive console right here. Let's see, which you can actually see code depth equals 4 now. I didn't type that all the way. And so now if I look at it, I don't know if it actually modified it. Let's see. Next line. Yeah, it actually did modify it for after that line executed. So it updated those. So you can actually modify the code as it's running the chains. Like, oh, screwed, I forgot to make that one little bit change. Or actually, I don't want to set up all the things to do to make this situation happen. Except, like, I expect this one thing to come false. It talks to the external server. You know, I'm just going to run it to this point, and then I'm going to change the value to false here instead of having to figure out how to make the external server return the false value. It is an easier way of interacting with some of your code, especially if you've got lots of breakpoints or feature flips, and you just don't want to set up all the situations like, hey, just run to this point, and I'm going to modify in place in the code, in memory, to say this is actually false, so I could hit this path and see what's happening. So lots of cool stuff in here, and you got watches you can add to be able to see what's always going on. That'll always run, and you can just see what they were if they're important. You got the stack trace to go see what was happening, so that's also really helpful when debugging. Just go like, how did I get here? What values were there when it got here? So you just step through all of them and see what's going on. So this is just a really powerful debugging tool. I love. This is one reason why I'm stuck on Chrome. Just it's such a nice tool to be able to debug JavaScript, and being able to have it included with Node now, or the interaction with it, is awesome. Oh, and it uses efficient technology like WebSockets behind the scenes, so it's not constantly pinging. Same with the other inspector, but yeah, it's not going to be. It's as least invasive and slowing down as possible as it can be for the technologies they're using to be able to attach the node. So that's pretty much my entire presentation here. I'm just pretty going to open up for questions.
Why did that move into that VM?
What you mean? Which VM?
So when you added, if you go to debugging.js and you added that console log, but then it switched over to VM58 debugging?
I think that's because of virtual memory is what I was trying to say.
Virtual machine.
Oh, virtual machine, yeah. So I modified it, but I think it needs to reload it because it was already executing the script. It's kind of
If you're stepping in and you just keep stepping in, eventually you're going to step into the VM. The VM is what is running all of your code.
Okay.
So
Yeah.
like if you're calling, an AJAX call, well, underneath there's an AJAX library, and that AJAX library is written into the VM.
I see.
yeah. If this was in a loop or in Express.js, then I would be able to more easily show you live editing, which I could show you right now with against bin/. Here's some live editing of feature flip. So told to stop the first thing. I'm going to tell it to just run. Do I have breakpoints already set up? Yeah, I do. So already got it. Remembers based off the script what you're running against, what your breakpoints were. So that's kind of nice. So it has memory in between, and you can. If I were to stop this is the other cool thing. If I stop this, it's like, oh, lost connection. I can start it back up, and because it's against the same script, I can tell it to reconnect. Usually. Well, it worked the last 5 times I did it. Sometimes that works. Sometimes you just have to copy a new URL. So now I'm going to hit host 1992/feature test. That should hit my debug point right here that I set. So this is like debugging here. Let's see. Let's just do a console log for the next time. Type of, yeah, this should console.log here. Okay. All right. I said save. Maybe that change this file will not save to the file system. Okay. So now maybe that's what I need to do is push save. Okay, so I didn't commit them to back to the virtual memory. So now it's printed out to my console right here. So live re-editing of the file without committing it to my file system is kind of nice. And I'm inspecting what's going on. So I can, all these things that are going on is to be able to make the feature flip work. So any other questions?
Anybody? Questions? Anyone having trouble debugging their stuff?
Theoretically, you should be able to use this inspector also through SSH, but you'd have to make sure the ports somehow map back to it, which can be the harder problem with if you're in a production or integration environment, is getting back to the ports.
Do you use the async debugging much?
I know it does do async debugging for native promises. I saw an error come through for it. It didn't actually bring up an error like it called an unhandled rejection I was having before, just because my database was out of sync with what it should be. And so, but it wouldn't let me catch that error and inspect it, but it did print out all the information nice where I could see it. Like these are all promises and they're all async, so it's letting me debug inside of them.
So you can put
and there's also, yeah, so there's also, Node generally runs with a single thread, so it's hard to, you don't generally have multiple threads unless you're specifically trying to make that happen. There are specific workers you can set up to be able to execute things as a separate thread, and those are, but they're not very common, and there's not usually good reasons, or very many good reasons to do that in Node, because its power comes from it being single threaded and how it executes things, because Node knows that rather the design principle behind Node is because there are a lot of things on computer systems that take longer than it takes to execute the code. That's why it's single-threaded, because single-threaded is also easier to program against and think about. And if you have multiple processors, the idea is you just spin up more nodes on the system, more of the same process on different ports or whatever. And that's how you can get some multi-threading going on. But yeah, because a lot of things take longer, it just has an eventing system that comes back like, oh, I finally heard back from this long-running process. Now I'm going to execute the code against that. The idea is you're not supposed to have much computational stuff going against those things. They should be really quick scripts. So if you start getting 300 milliseconds longer, you're going to hog the server for a response for 300 milliseconds. So that's where you start getting a problem. Same problem with Ruby. Has the same problem because it's also single-threaded. And that's why they have background workers or things like Sidekick to do longer running things so you don't block the whole server while doing it. So
if you're writing code, say 300 milliseconds, most likely there's a big error in the code.
or you're like trying to compute Fibonacci and you really shouldn't be doing that. And go to a language that does that better.
I'm going to, in the near future, be doing performance, JavaScript performance class, so we'll go over a lot of that type of stuff, do's and don'ts.
Well, like for API calls and stuff?
API call, so the whole thing is with the event loop is it's non-blocking for I/O. Okay. So your code's executing, your code makes a request to read from a database, to read from a file, to go to another server and read from that server. Those are all I/O. Anything that's I/O gets offloaded to the libvb library and is running actually, yes, it is running in a separate thread over in the libui stuff. Your JavaScript's not. But your JavaScript does not continue, it continues doing other things while that's going on. And when that's complete, like John said, then it gets and continues your code. So just because your endpoint's taking 300 milliseconds doesn't mean JavaScript's not running for 300 milliseconds. It just means that it probably is actually only running little bits of code through here and there.
Yeah, you only come into problems when it's the JavaScript server that has to do computations. Like, oh, I'm going to start joining these objects together instead of letting the database do it. Okay, that's probably not what you should be doing, but it's going to take longer to do that. Or a sort operation on a large amount of content is going to hog your server's memory and resources and cycles, and it's not going to allow other requests to get through. They're going to be waiting for the server to respond. So that's what you want to avoid. But for the most part, a lot of the Node frameworks are designed to help you not do that if you follow their best practices and their things. You can still do that. You can still screw yourself, but if you follow the best practices and make sure you're cognizant of what you're doing and realize that it's a single thread in anything you do in your code, if it doesn't go out to an I/O for time, then if it's just sitting there crunching for 300 milliseconds, that's 300 milliseconds your server can't talk to anybody else.
Right.
So, all right. I think I'm going to close this down unless there's any other questions. Okay. Well, thank you guys for coming. I appreciate your attendance and participation. And feel free to hit me up for questions or Ruben afterwards for any of this material.
Hey, John, would you mind like emailing out like the slides and resources and also that debugging file as well?
Sure. Yep, I will do that.
Cool. Yeah, we'll get the email, standard email sent out.
Yep.
Um,
And I'll get this screen recording probably up on YouTube too, so you can watch it.
Do we have a central